Hello? Is anyone here who would be willing to take minutes for this session? We need a minute taker or we don't get to have a session. So would someone be willing to take minutes? Okay. We have a Jabber volunteer, minutes volunteer. Thank you. Okay, I guess it's time we're going to get started. So we'll just, anybody needs to come in, sit down. Okay.
All right, so we thanks Dave take JavaScript and Ian helps take minutes. And so this is a multiple interface working group, and here is Prague. And so Margaret and I am chairing this working group. So this is a newly updated nowhere. Please be aware of the IETF's rule. We have nowhere if you are in here in IETF meeting. And so today we have agent. This is our agent. So we have 4 topics today. And first we are going to talking about the agent bashing, and later we have a little bit short mention about current 3 working group last call, and then we go to the area where present the MPVD API designing, and in the last we are going to talking about home network proposals. So is any agent bashing here? No. Okay. So yeah, firstly we have one of our working group draft has been published to the IETF93-MIF-20150721-1520. That is about our MPVD architecture document. I think Dimitri has did a very good job, and he's not here, but I think he deserves something applause from here. Right. So the second, we have 3 working group last call. We started a working group last call last week, and we intensively to have 3 weeks working group last call to allow you to read the document later after these IT meetings. And so we need at least 4 and 5 very substantially review for the DCP and NDP support for MPVD ID documents. So please help to review the document and okay.
Is there anyone here who's willing to commit to review one or both of these documents over the next week or so? A couple weeks? Is anybody? Okay, thank you, Eric. That would be great. Anybody else who could review the DHCP and ND support documents? That'd be great, Ian. It would be at least good for you to go through and make sure that you're happy with that everything was properly addressed. I mean, I'm sure the authors meant to address it, but let's make sure they got it right. Anybody else who could do a review in the next couple weeks? Excuse me? Well, I don't know. Are there open comments that are unaddressed that we want to talk about? Are the authors here?
Oh, this is Eric Klein. I don't know if the authors are here, but I haven't even had a chance to finish reading your email yet, Ian. So it seems to me that there's definitely something worth.
That makes me feel better that I hadn't seen your comments. I guess I just haven't. I'm not up to date enough.
Yeah, no, it was from this morning or something. Yes, or last night. Yesterday, yeah.
Yeah. So I mean that is a last call review. That's great, and we'll just work with you to make sure that all of them are addressed. Are the authors of the DHCP document here? Shresh? No. How about the ND document? Who? Okay. Yeah, the authors aren't here, so I think trying to have a discussion of something that was posted to the list this morning without the authors here would probably not be useful. So why don't we discuss it on the list, because hopefully the authors will be getting back to Ian shortly.
Right, so next will be Eric. Will present the. Do we have mics over there? You standing over there? Yeah, this kind of audio.
This is a pointer. Oh, there's the microphone. Yeah, you have to stand there.
It's a bit like being banished to the dark corner of the.
And I don't know if you know that you have to stand in the pink box for some reason.
This is the pink boxes for
and
cameras.
We have stickers we need to give to Jabber scribes.
But the only camera in the room is on the chairs. Okay.
I don't see any. There's supposed to be star stickers here.
Oh.
Blue sheets.
This one's
Sorry, Dave, you don't get your gold star because I don't have any. Oh no, over here. Give Dave those stars. Let him take one. We don't make up these things. I don't know. Never heard of this before. It's a new thing. I don't. This is, I think, a laser pointer. I don't know what it is. Why don't you try it? Well, it doesn't. What would it enhance though? But I mean, they're on me's laptop. I don't think that's. Is it? Even I don't think he synced it. Do you want to sync? Why don't we just say next?
Yes, to say other.
Yeah, because this apparently could be hooked to your, but I don't know. Yeah,
Okay.
hook up a random Bluetooth device to your.
Should I get started?
Go ahead. Yep.
Okay. I'm Eric Klein. This is going to be essentially me attempting to kind of POSIXify a bunch of what the application layer stuff looks like for the multi-networking things in Android. And also some of the discussion around what is required on the kernel side or what is expected of the system. This is mostly the application layer consuming side stuff, how the server side, service side builds the notion of what a provisioning domain is, that sort of thing. That's all probably has to be a separate document and is also worthy of considerable discussion. This is the multi-networking Android work was done by Lorenzo Coliti and Robert Greenwald and Paul Jensen and Sriram Ramachandran for Lollipop. Anyway, so next please. Let's see here. So per the architecture document, PBD is a consistent set of configuration information, and that includes the participating interfaces. It includes the addresses. It includes the routes, and not just the default routes, but any more specifics you might get inside of RIOs. It includes your DNS servers and your search path, and whether or not you have an HTTP proxy. And it includes things that we haven't yet thought to include, like hints about metering or hints about what medium is these interfaces may be traveling over, like 3G, LTE, etc. Whether or not there's a captive portal URL, you need to check first. And so, also a key thing to note also is that this information is not never learned atomically. Like you get stuff out of RAs, you get stuff out of DHCP. and it's also not static. Especially if you include your addresses, and especially if you include lifetimes of addresses as part of this configuration information. Every new RA you get means that those addresses are refreshed. So if you include all of that information, then it definitely gets updated frequently, at least once an RA. As we saw in the last v6 off session, that's about once every 3 seconds. So next. So what sort of things do applications need to make use of PVDs? First, they need a way to sort of get this configuration information, and they need a way to sort of get notified of updates or changes to that information. They need a way to be able to select a provisioning domain at various levels of granularity. That's very helpful in Android. There's the notion of the system default, right? That could be LTE, and then you bring up Wi-Fi, and the sort of system default swings over to Wi-Fi. And most applications don't know and don't care. But sometimes it's very handy to be able to set a per process to specify everything that this process does with the network should be in this PVD. And sometimes you might want to be able to say per thread and per file descriptor. In Android, you can do all of this except the per thread stuff. We don't have that yet. The system also needs to provide some sort of socket level control. This sort of goes hand in hand with the PVD selection by file descriptor. You need to control the routing and the address selection. The application needs to be able to specify this stuff. You also need help from the system to sort of automatically tag incoming traffic with the PVDs. So if you get a SYN, you want the results of that. You want the application needs to be able to sort of issue a SYN. The kernel needs to issue a SYNAC out the right PVD with the right routing table. So if I have 2 interfaces come up and I have a SYN coming in on mobile and the default interface is LTE, I don't want to send my SYNAX and be talking like this, right? Incoming. This is MIF, and we're trying to do better than that. So DNS resolution. You need to know which servers in the search path to use, and also, like I said, you need correct routing to these DNS servers. You don't want to query the right DNS server on the wrong network. And if you have the socket level control, as we'll see later, you can actually implement that part easily. You also need to get useful errors, right? Applications need to know net, there's no network there, or host unreachable, or other kinds of things. Default. It was inval. That's the most useful one. It's like general protection fault for Unix. Next, please. So a digression on source address selection and routing. Is Ule in the room? Okay, good. So I can say here that addressing and source and routing are integrally related. In fact, for MIF, they kind of have to be. And so if a PVD has been specified, it's recommended that the source address selection be restricted to PVD addresses only, right? This is an update to RFC 6274, section 4. There's a recommendation there. It says it is recommended that the candidate set of addresses be those on the outgoing interface. And in a multiple PVDs to interfaces M to N kind of mapping world, I think we should instead sort of change that or append that to say it is recommended that the candidate address set be that of the provisioning domain. Which for simplified cases like Android where the provisioning domain and the interface is one-to-one, ends up being the same thing as the outgoing interface, but it's not necessarily the same thing. It is still important to return errors. Like you might have 2 PVDs, one that's v4 only and one that's v6 only. I have this constantly in my work environment. And so, you need to get no proto support or address not avail or host unreachable if you try to talk to a v6 address on a v4 only provisioning domain, even though you've got dual stack or v6 only on some other interface. Destination reachability. When you try to reach a destination, you have to use the right routing table. You have to use the PVD's routing configuration information, which I'll probably call a routing table since that's how it's implemented, but you need to use the provisioning domain's routing configuration information. User space libraries often use the connect trick, the UDP connect, to get a source address from the kernel for a given destination. This has to be using the routing configuration of the provisioning domain. Otherwise, you will try to do a connect to you can get a quad A, you can connect to a v6 address and use the source address from another provisioning domain, and you're in the precise world that MIF was designed to fix if you don't do this right. And this plays into getEditorInfo and AIEditorConfig. AIEditorConfig documentation in getEditorInfo RFC 3493 says an IPv4 address / IPv6 address shall be returned if an IPv4 / IPv6 address is configured on the local system. And that has to sort of be amended to say, I would say, if an IPv4 / v6 address is configured within the requested provisioning domain. So you want AIEditorConfig to do the right thing. If the provisioning domain has no v4 addresses, don't do an A lookup. Next, please. So there's some new things to define, and this is the only slide that will be about them because I didn't have a list of specific function names to come up with. I'm terrible at naming. Dapeng's document has some pretty good names, I think, but I had a question for the C and C++ sort of programmers, POSIX programmers in the room. What is an extensible way to get configuration information? Is it a struct with pound ifdef extra members? Is it a kind of a get sockopt call where you know, if you have this member defined, then you pass in a void star and you get it filled back because you know what it is? That's at least kind of more flexible. Admittedly, C++ doesn't have a lot of awesomeness historically in this area. If we could have some awesomeness, that would be great. I think it might even be that a combination of both is correct, that a get PVD info option that has the sort of agreed upon minimum set, and if we need to add stuff later, we do so in some other fashion. We'll need a way to get notification of configuration changes. On the Android operating system, this is done with something kind of like signals. A callback is sent to you, basically. And we need to figure out a way how to express the PVD interface / scope ID relationship. Right now, I mean, for us, it's one-to-one. But if you were interested, if the application were interested in knowing which interfaces this provisioning domain is, if named to index is not suitably equipped to help us right now. So we'll also need a new command to get and set the process default PVD, and a new command to get and set a thread default PVD. And we'll need a symptomatic we found it helpful to have a symptomatic programmatic way to refer to PVD instances and not necessarily by their identifier, however flexible they are. Yes.
Hello, Ian Farrer. So you've got the idea of the default PVD, which, I mean, after the document was published, and I thought more about how how it was defined in there. Default PVD is not a concept that the architecture describes.
Right.
And I think it's missing. I think that there needs to be some way of saying, if nothing else is supplied, this is what you fall back to. And so, I mean, it's not just a question of saying, how do I invoke this, but the whole construct of what a default PVD is and how it behaves needs to be, the architecture needs to be extended with that.
Yes. I mean, well, so we found it handy for the system to have a concept of a default PVD. Now, if it's sort of a system-specific thing, I don't know.
Well, I mean, so I started thinking about this for saying, if you take a generic Linux box or something like that, and you've got a load of etc configuration files for resolve.conf and all of these kind of things, where do they sit in the provisioning domain architecture? These are things that people are used to using, things that people rely on and will continue to use. So how do they sit in there? Because that kind of stuff is never really defined. So this kind of leads to saying, well, there is a default PVD. That's where that stuff belongs because it's not expressly put into a defined or an explicit PVD, to use the.
So that is slightly different. There you're talking about an implicit PVD.
But
there you're talking about the system itself. The system, the non-application side of the stuff, the system side of this is going to have to decide what to do with all of the implicit PVD information. Is it separate per interface? Are we just going to treat it all as one blob?
Right.
And that's sort of out of scope of what we're talking about.
So is your concept
now,
of a default, is the default an explicit PVD in your case?
No, so as the final bullet point here is that, we have this PVD unspecified thing, which is basically saying, which is pound defined to be 0. And it's like, if I didn't say what it is, then you do the right thing for me. right?
Right. Okay.
I open a socket and I want to call connect.
Yeah.
So, do source address selection for me and send us in out the right interface, and whatever the system thinks is best, that's fine with me.
Yeah. I mean, I think that works fine if you've got a single implicit PVD. That kind of works. But this potentially, if you've got per interface
in Android,
implicits,
everyth's explicit.
Everything in your case, but
the
again,
idea
the
is that the
architecture
application doesn't have to know anything about it. So no application needs to be modified.
No, but as you get, if you have multiple implicits from multiple interfaces, which again I think the architecture does describe, then the unspecified, what to do with the unspecified becomes much less clear.
Margaret has inserted herself with the line. We had a discussion this morning, and she came up with another possible interpretation of what unspecified might be used for.
Okay.
So it might be the case, and I'll let her describe that though.
Yeah. Okay. Stephen Bart. I was just thinking, is the default a single PVD or is it a set of possible PVDs? I think that's discussable as well, because if I have, like, I don't know, maybe let's use a simple case of I having multiple uplinks, then in some cases I just want all my applications to by default use any of them that work for that specific destination, or I might set a default as a single PVD. I mean, that's not clear either for me.
I think the answer is standing behind you.
Well, first I want to say at the beginning that Margaret Wasserman or Cullen or something. I'm changing my name, which I haven't completely done yet. So my badge says Cullen, but the city of Prague thinks my name is Wasserman. It's complicated. One thing I want to say is that when we make this API, and this API, bam, it's there on Android. On day one, absolutely no application will call it. And they still are going to make the old calls, and they're not going to specify any PVD, and they've got to get some sort of sane behavior. Okay? So we already have to have something in there that gets a PVD for you, that figures out where you're going to send your packets, and sort of assigns you a PVD when you haven't specified one. And in my opinion, the unspecified one should be like when you don't specify a source address in bind, the stack gives you one. When you don't specify an outbound interface in connect, the stack gives you one. And it should be when you don't specify a PVD, you get the right one according to the stack, which might not be the right one, okay, but it's the same one we give you today when this API doesn't exist, right? I mean, applications are not going to know to ask for one at day one, and there has to be something we give them when they don't ask for one.
But it could also be like trying to connect to the unspecified address. You get, host unreach or destination unreachable.
Yeah, but I don't think we can't do that, because then every application that exists will stop working because they can't specify a PVD.
Yeah, I certainly, I don't see many people not defining one. It's so terribly convenient, but it might be important for people to have the option to say that if it's unspecified, then nothing should happen. We have to force the use. If somebody wanted to force the use of the API, for example, that could be handy.
I had one comment. Like, I mostly agree with what Margaret said, but one of the things she said was like it'll return the same thing as today, but that's not a given. So since like everything is a mess today, all the stuff is getting mixed up, right? So tomorrow we could give a better answer even without the application asking for a PVD. Okay, so we want to leave that open, right? So the calling with unspecified doesn't always result in the same behavior as today, if there's like sources actually separating the stuff into PVDs.
And it certainly doesn't result in the same behavior over time either as whatever other PVDs come and go on the system. Yeah.
Stephen Bart again. I'm also wondering, you said there's like defaults per process, per whatever in the last slide, but that's another thing. When do you want to make that sane decision for the specific application? Do you want to make it when the process is spawned? Do you want to make it?
The application makes that decision for itself.
So the default, but
the application makes that call. The application says, set this as my process default. And
but if the application doesn't send it, which is like the default, which we were talking about, I think, or the unspecified case, when is that determined? Is that determined at application start, or is that somehow affected by changes in the network interfaces later on in the process when the application is, or the process is still running, or is it just defined that when I open or connect the socket, then this is reevaluated? I mean, this should be clear in some way, I think.
It's dynamic. If it's unspecified, it's evaluated when you make that call.
So what you're saying is, if the application doesn't make per process per whatever, then it's determined when I open the socket, right?
Correct.
Okay, I guess that should make sense.
I mean, not even really when you open the socket. It's per the few slides back we had a discussion about source address selection. Once you've selected a source address, you're kind of committed to it, really, in MIF. You can, if you want to use a source address from one PVD and try to send it another PVD, good luck to you. But that's the situation that we have today, and the thing that we're trying to do better than.
Yeah.
So
but
you can do that, but best effort. Good luck to you.
Yeah, I'm just thinking about the corner cases.
Once the source address, once a source address has been selected, that's sort of where you're going to be for the lifetime of whatever that is. That packet, that file descriptor, that socket connection.
Yeah. Except that sometimes it doesn't when you just bind your socket to the unspecified address, and then if it's a UDP socket, for example, you can just send packets anywhere, and then it's supposedly defined at packet send time.
Selected at that time, yeah.
Yeah, then it's done each time I send a packet, right? So probably okay. That's an interesting choice.
Well, so it's talked about in the slides later about what I think we should have.
I'm Danny Moses. I wanted to relate to what Barbara said. It sounded like she's suggesting something which is nice to have, and I don't think so. I think it's a must-have because it's about backwards compatibility. You can't expect all existing applications to stop working or to work less optimal than they work today just because you bumped the version of the operating system. So once you introduce awesome features in a new operating system, you still have to support existing applications in the same level as you did with the older version of the operating system. So it's a must-have.
So Margaret first.
That I don't disagree with that advice, but that's advice about an implementation. And not about the specification of the sockets API. Right now, if you don't say anything about what source address you want to use, the stack chooses it for you. Okay, that's all the sockets API says. You could change every time you put out a new version of Android. You can make it use a different algorithm to pick which address to use, and that would be between you and your customers. You'd still be sockets compliant, right? If you don't pick a PVD, the stack should pick one for you, but it's probably going to just run source address selection and then give you the PVD that matches the source address. But that isn't, I don't care. I mean, you could change that in later versions of Android if there comes to be a better way to do that, and you'd still be compliant with the same sockets API. Does that?
As it stands now, and both in terms of how it's implemented and also what I'm recommending, basically, undecided is undecided until a decision has to be made.
Right, and when you pick the source address, you've made a decision because that source address, because of the fact that you do a one-to-one mapping of PVDs to interfaces. Now, if you ever get to the point where that interface could be in more than one PVD, you're going to have to make a secondary selection to pick the PVD, right? I mean, I understand you don't do that now, but it can be, we don't have any direct mapping of interfaces to PVDs. An interface could be in two PVDs. Mm-hmm. Two interfaces could be in one PVD, like definitionally. Mm-hmm. So that it might be that you have to do a source address selection and then a PVD selection if for some reason but I don't think you'll ever get the case where one source address is in more than one PVD because you'll probably have two addresses when an interface is in two PVDs, but you at least theoretically could be making a secondary choice if you get to the point where for some reason you implement a case where there could be more than one PVD on the same prefix.
So two PVDs on the same interface with the same IP addresses?
Well, I mean, I'm not sure what that would do. I think that would be conceptually like you've got a NAT, but really you've got two connections out the back. But since there's no way to trigger the CPE in that case to actually choose the right way out, I think you end up being faked into thinking you just have one PVD, even though you kind of have two, right? I mean,
so both of which are implicit.
Yeah.
Well, I don't know.
But anyway, I think that once you've chosen the source address, right, I think for most of the implementations we're likely to get in the theoretical future, once you've chosen the source address, you have chosen the PVD, right? So like you were saying earlier.
I think that should be the case, yes.
Yeah.
I mean, if you wanted to transmit on a different PVD, you should be allowed to, and good luck to you. But yeah, Lorenzo?
So Mark first. Okay.
Yeah, it was just Mark Townsley. I was just going to underscore some of the things that need to remain implementation dependent. While we might think that, oh yes, when you bring in something new, you must be able to not break the old applications, et cetera, we should also be able to bring in new devices, maybe a VM running on a device that runs in a constrained manner that you want to be very strict about, and you want to break if someone doesn't specify the PVD or that camera or that speaker or something, right? So the flip side exists here. So keep it out of the specification, let implementations do the right thing.
Just to talk about an earlier, Lorenzo Colidi, just to talk about an earlier point, I think it's, I think in practice, when you're doing source address selection, you don't have enough information to choose a PVD. There's sort of, a lot of them just look equivalent. And so what ends up happening, I think, is that you pick a PVD using some other means, you know, either explicit preference or whatever happens to be the default at the time, and then you do source address selection constrained by that PVD.
I would like to provide more information so that a PVD and therefore the associated source address could be chosen in a more intelligent manner for that particular application. That is a very specific thing that I think that we should be able to hook up all the way up from the network to the application through things like the properties and classes, et cetera, drafts that we have for DHCP options, for RAs, et cetera.
Right. I mean, I agree with what Lorenzo just said for PVD-aware applications, right? If an application picks a PVD, that PVD could include 2 interfaces. It could include 6 prefixes. You know, theoretically. And so the source address selection has to happen after the PVD selection in that case. But in the case where an application doesn't specify a PVD, it could be an application that has been written after the PVD sockets API exists, but that really it doesn't care what, it wants to go to 10.1.0.3 wherever it can. And there may be a case where if we're on 2 net 10s and they're in 2 different PVDs, we have to flip a coin, okay? And we don't get better than we get today.
You would have the eyeball at that point, right?
No, that's where the thread
happy eyeball it, right?
Default.
This is where I get to, let's not say how the implementation chooses it, because later you could get happy eyeballs and you're going to choose the right one, right? So you could try both, you could try only one.
This is where a thread default, you know, a process default and a system default sort of apply. If you didn't specify one, it's already chosen for you.
We sort of tried that and it didn't work. So
well, I mean, it's what we have now, but if they don't specify one, okay, we can't make them specify one. Today's applications don't, and they're going to continue to sometimes not work.
Right, and there are defaults basically that are it's chosen for them unless they choose otherwise.
Right. Let me perhaps elaborate a bit on what I mean when I said we tried it and it didn't work. So when in Android L we said, oh, we have this new multi-networking thing, it's great, it's wonderful, and so we said, well, before we're switching to a network, we're going to evaluate it for internet connectivity. If it doesn't have internet connectivity, we're not going to switch to it. It's just going to stay there in the background until we validate it. That sounds good. And then you say, well, I've got my GoPro camera, it's on a wireless access point, how do I talk to it? Well, it turns out you couldn't, right? So we came up with a variety of hacks, and one of the things that we considered doing but ended up not doing is, okay, well, you've obviously got local routing tables. Let's put all the routing tables somewhere and let's use source address selection somehow to figure out what happens. And that might almost have worked, except when somebody said, well, I want to type routerlogin.net in my browser, right? And so what happens then? I don't know. The only idea that we had at the time is fire off a DNS query to routerlogin.net on all the interfaces and then cross your fingers. And we ended up saying well, that's not a good approach because it's kind of really bad in the general case, and so we instead went for other solutions. So so that's why I say the PVD kind of, you need to know before you do source address selection which one it is, and how it's picked doesn't matter, right? It can be picked automatically for you. But I think source address selection often doesn't have enough information. It's sort of a lot of policy and a lot of defaults and stuff.
One last thing. Sorry.
It all out of the sockets API itself, because I think over time people are going to come up with better and more clever ways to do that, one hopes. Yeah.
So Stephen Broad again. One last time for now, sorry. But do you think it makes sense to have not an explicit PVD selection, but more like a category or attribute selection? I mean, just bad example, the old TOS. I want this traffic to be with low latency, or I care about bandwidth or so. Is that supposed to be there or not?
There's nothing stopping you from using the old socket stuff to choose an outbound interface, right? You could look at the interface characteristics and choose one if you want to. This is in addition to the old socket stuff. It doesn't take any of that away.
What you're asking about, if I understand you correctly, is implemented with this stuff. What you would do is you'd say, give me all of the give me all the PVDs, and then you'd go through all of them and ask for some feature that you want. Give me the bandwidth attribute of each of these PVDs, and then you would just sort that in the list and take the max.
For example,
and then you're done. You could implement it that way.
So
I would argue that the bandwidth attribute wouldn't be an attribute of a PVD, because a PVD could have 3 interfaces with different bandwidths. A bandwidth attribute is, I would argue, an attribute of a prefix, right? That when you use this prefix, the outbound thing is going to have this bandwidth. Because if I have both like an LTE connection and a DSL connection to the same provider, and they're the same PVD, that doesn't suddenly make a DSL connection and a LTE connection have the same bandwidth. If I happen to be here in Prague and my phone is doing Edge for cellular, Wi-Fi is much higher bandwidth than the cellular interface, but they're still in the same PVD. So it's a per prefix attribute, not a per PVD attribute.
So would that essentially mean that we now not only need an extension for the PVDs for the socket API, but because I guess this is what we are seeing in stuff like Android apps or Apple apps, where you can say, oh, I don't care about that much about the service, please only run this over Wi-Fi. So now you're saying I can't do that with PVDs, but there should be another way for this, right?
Well, I mean, for one thing, I don't think, first off, lots of OSs have ways to check the attributes of the interfaces. As far as I know, they're not part of the sockets API. But I don't think that would necessarily be a MIF thing either. I'm not sure. I mean, someone would have to make a proposal. I think it probably more like a 6-man thing or something. But but there is no such thing as the bandwidth of a PVD. It's not a PVD level concept.
Yeah, I mean, it was just an example, but you're saying this is out of scope for MIF, right?
I mean, we can have, like in MIF, we can have a node that's sitting inside your home only attached to Wi-Fi, but you have a cable modem and a DSL, and that's still a MIF node. It has 2 prefixes, and it's not going to know anything by looking locally about the bandwidth of those links, right? It would have to get something handed down to it, but it would be, I think, a per prefix piece of information, not a per PVD piece of information.
But with this stuff here, you could query for all of the PVD to interface mapping, and you could look at all the interfaces and decide which one looks like it's fastest to you, and then use that PVD for your communications.
Yeah, I mean, except that you might have 2 PVDs and only 1 physical interface, so they all look the same speed to you, but they could be very different speeds. But then you can't say, well, 1 hop away they're going to tell me how fast their 2 links are, because it's like maybe that's still inside your home and you still don't actually know the answer. It's like a recursive thing. I mean, I suppose I could write a protocol that all the way across the internet will come back to me and tell me how big the links are all the way to Microsoft, and because I happen to be looking at Dave, but and then pick my prefix based on which summary of those links is fastest. But that's not it probably won't stay that way long enough to make the choice.
That would answer. You can always construct a situation where we couldn't construct an answer, right?
Well, I mean, I think that very much the case, it's not a PVD level concept, because a PVD could be 3 outbound interfaces are all 1 PVD, and they have very different properties. So you can't say what are the interface properties of this PVD.
So
I think that's sort of clearly, I think you've hit essentially what the conceptual boundaries of the concept that we have. That's what it, like we built something that, I mean, the way I see a PVD is it's intended to survive. It's intended to avoid configuration errors when you have more than one network and you pick the wrong combination of DNS server and source address, things like that. But it's not really, it doesn't really have enough information to do this sort of thing, right? What you might have to do in that case, you'd pick the PVD and then you'd also have to have another specified that specified the interface, and then even that would only work if that interface were directly connected.
Exactly.
Right? You'd have to choose, like in a home net situation, you'd have to choose the source address that was then, that you knew then somehow using some magic that was mapped to some outgoing interface that had a certain bandwidth. That this is
right.
So I don't know that we
the magic could be RAs, right? I mean, or something like that, but nobody specified anything like that. And I think it's problematic because the fact that the next guy up might not be the outbound box.
Right. So you can try in HomeNet, you can try to propagate it through the mesh, but I think fundamentally we don't have a concept that even defines this, and so perhaps. One way to think about it is that you say, well, let's build something that can send the right packet out the right interface without making a stupid mistake, like use the one on the wrong PVD, right? That's the first thing you do. But then you've got all this other policy stuff and predicting what's going to work best that PVDs, I don't think, actually help you answer the question. So I don't know how to fix that. But I think trying to fix it using PVDs is not going to work well.
Markus Temberg. Actually, something stuck a chord with me in the previous answer by Margaret, I think, which was that, PVDs are the wrong level concept for making these decisions. You have to actually make them by source address. But then the question becomes, is PVD actually correctly defined? Because if I don't get, for example, better quality of service out of using them, and I have to anyway write some hacks that use some undefined yet another API, and I yet have to propagate that information using something else than PVD, then what's the point? I mean, okay, fine. I can identify with some set of prefixes, but I don't get actually any guarantees about what sort of transport is there really, because if it can be a combined PVD, which has like anything from my modem, cable modem to something like, I don't know, 1 megabit wireless link, then I wouldn't want to use that. I would rather use just a specific prefix and be done with that.
I mean, the PVD gets you much better service in those cases today where you get no service at all. Okay, it solves a whole bunch of cases where you get no service at all because you're using the wrong prefix to reach the server you're trying to reach, or you're using the wrong DNS server to look up the DNS name you're trying to look up. And that's the cases that we're trying to solve. What you're trying to say, it seems obvious when you're looking at a very small case. You're looking at a cell phone that has two interfaces, and if you look at a cell phone, you have two interfaces, you want to know what their properties are, look at the interfaces, okay? If you're in a home and you've got a box that has two interfaces and you want to know about its interfaces, you have a way to tell you, but that's only telling you about the first hop. You know what I mean? That's only telling you about what your home is connected to. It doesn't tell you that the guy on the other end has a very slow link to Comcast and a very fast link to Verizon, and that actually the sum total would be better for you to go to Verizon, even though your link to Verizon is slower than your link to Comcast, okay? Knowing the first hop is...
Well, just first...
Even if you have only one interface and a VPN on that interface, they both have the same speed.
Yeah.
And the VPN may be faster depending on the destination you're trying to reach.
Right. It may reach it, and the other one might not. Like,
and there's that, yeah.
Yeah, but the point is that the multi-prefix case, from my point of view, is just pointless because if you can specify everything for single prefix, then it works also for a multiple prefix case, but you duplicate some information. But on the other hand, the cases with bunch of prefixes with shared characteristics but very different transport are weird from my point of view.
The idea that you would have three things in the same provisioning domain, say, three interfaces, and they are all attached to the same provisioning domain would be very useful for an application like multipath TCP, or something that wants to load share across those interfaces or bandwidth share across those interfaces.
Yeah, sure, but this is only because you assume you can use only one PVD. If you can actually use multiple PVDs, then you just choose that, please use any PVD that can reach google.com and Bob's your uncle. Then you can eliminate those that have actually, for example, cost function that you disapprove of.
Any PVD that can reach
something.
google.com is easy to say and hard to determine from where you're sitting.
Well, okay. Happy eyeball for the win, but...
So I've been standing here for quite a while.
You were competing with a Norwegian, though.
Yeah, finish.
Finish.
Doesn't this get a lot easier if there's one PVD per prefix? I trying to understand exactly why we need to have, all these possibilities and groupings, and if it's one PVD per prefix, because we've got this idea that there's something being provisioned, and then after it's provisioned, once it gets on the network, it kind of knows what to do with it. That sort of matches that metadata that was provided when you provisioned it so that the application does something. And so there needs to be something that's common between that provisioning that the application can see and that the network can see. And an IPP source prefix is one thing that they can all do. Once you start saying there could be more or less or different combinations, the complexity level goes up a lot. So if we need to do that, okay, but let's be sure why.
The biggest reason we wanted to do that, the thing that came up the most, was the idea that a V4 and a V6 prefix on the same interface may be using the same DNS. I may just have a V4 DNS. I got that from DHCP V4. The PVD name on that was Mark's Home PVD, but he also gives me an IPv6 address, but that IPv6 stuff comes from RAs, and I don't get a DNS server from them because it's not set up to configure it. I want to use the V4 one because I know they're in the same PVD.
Yeah, it sounds good on paper, but then if you need to support V4 as well, you don't have one prefix per PVD anymore.
Then don't, but right. Can we somehow partition the V4 out into its own set of PVDs? Because, I mean,
No, because you don't know if the destination is dual stack, for example.
What if my only DNS was on V6 and it's in Mark's Home PVD?
But you would have,
I want for V4 to use the V6 DNS.
Well, it's back to this. If you have the ability to choose amongst your own set of PVDs, and you have the V4 PVD and you have the V6 PVD, the V4 PVD obviously doesn't have the source address thing to help distinguish, and then you happy eyeball between them because that's what we do today anyway between V4 and V6.
No, but then the app has to select two PVDs, right? Then you're pushing all this burden on the app to select all the PVDs.
Okay, have a PVD group above it that the middleware provides.
That's what the PVD is the interface group. That group,
no,
what you just said, have a PVD group. That's what it is. I mean, it's a
not
group.
An interface group.
No, I mean, it can be only one. It can be. Right. Well,
I mean, if you need if you absolutely need it, but the nice thing about that is now one day when you have a V6 only network, you don't have all the V4 stuff hanging, cruft hanging around in there, right? You have a separate PVD V4. You have your PVD V6. You do the PVD V6 properly. And then if you need to group two together as dual stack,
we are currently trying to talk about an API for an architecture document that's already in RFC. I mean, so I don't know what to say. If you want to update that document, I mean, if you think it's wrong, write to us and tell us how you think that document, the architecture, should be updated. But we can't just make an API that assumes an architecture that's different than the architecture.
Any V6 only mobile provider that uses 464XLAT. That's two different interfaces with CLAT, and it's all in the same PVD, right? And if you want to split the V4 into a different PVD from the V6, then that's going to get really complicated for things, because AI adder config is going to be V6 only for one PVD and V4 only for another PVD, as opposed to just kind of like it's all part of the same provisioning domain. It all comes from the same administrator.
No, actually, the 464XLAT is the perfect case where it doesn't matter, because what I was saying is we need one thing that ties what happens on the network, what happened to the provisioning entity, and the application together, right? And the application, well, in this case, there's an application that's just thinking V4, and so it doesn't get all the fancy V6 features, but when the packet goes out on the wire, it's a V6 packet, right? Mm-hmm. So the network sees it as V6. And the V6, there is no V4 provisioned anything. It's actually, that one actually
works. There is in CLAT. It has its own interface, and it's, it's a virtual interface. It's
that's an implementation choice.
It's an implementation detail. But separating the V4 out from that would be worse. My point is separating the V4 out for that would be worse for applications.
I think anyway, the problem is RFC 6724, right? Source address selection. It a large part of its existence is to pick between v4 and v6 and order the results. And in order for anything to work at all in the PVD model, obviously source address selection has to be confined to a given PVD. Otherwise, you assume that stuff isn't going to work. So if you had two different PVDs for dual stack link, one v4 and v6, or one for two different v6 prefixes, because that's a fully supported use case, remember? So, even when v4 is dead and buried, right? You would basically have to do something to teach the app that if it knew which PVD it wanted to do, or even to teach the source address selection algorithm, that these two PVDs are somehow some one thing. Right? So I don't know that it would actually simplify anything.
Let's not have meta PVDs. What? Let's not have meta PVDs. PVDs
Well,
are
again,
PVDs.
the nice thing about a meta PVD is that you can separate out, get rid of the v4 part one day.
So Krishnan, just a suggestion for Mark's problem, right? So whatever goes into a PVD is like a choice on what you advertise. So if you as an operator wanted to take away the V4, there's nothing stopping you from pushing the V4 into a different PVD. So the PVD group is actually the PVD. So you can have a different granularity, right? So you can put all the V6 information and the V6 interface on a PVDX. And today you can put all the V4 stuff in the same PVD. So somebody who has a V4 only application like Skype or whatever can do it. But tomorrow there could be something in Google's implementation which says okay, if application ID is some shitty application like Skype, then it could also look in the V4 only PVD, right? So you can still keep things separate altogether, but that's the flexibility of the PVD. So it may not work right now, but at some point, if the V4 stuff goes away, then you can isolate those things and make special cases in the stack for pushing into a different PVD. Right? So I think Steven talked about it, some kind of I don't know, for lack of a better term, he didn't give a term, but it's something like a search order for PVDs, right? So if you say I prefer this, but put something else, it's probably too complex at this point, but we do a DNS search order, we could do a PVD search order.
I would push that on the app. If the app wants to try every single PVD on the system, let it do it itself. So
let's if we could just maybe close this issue. I don't want to get in a situation where you don't get through the rest of the presentation. So why don't we close this one issue and we can come back to it at the end if we get through the rest of the presentation and it still looks like we're okay for time.
Okay, so
next slide, I guess.
Can I summarize what we concluded just now? I think we don't think the link elements, information elements will be in the MPVD scope at this moment. And also we, at this moment, because IPv6 transition stage, we are not necessarily to mandate one prefix per previewing domain. We are waiting for the future. So that's we concluded.
Next slide, please. Let's see, some considerations for sockets things. We're basically talking about the strong host model sort of almost, except PVDs to interfaces is M to N. As I was mucking around in some of the Linux kernel things, I kind of noticed that PVD IDs are kind of what the site local scope was, or kind of like a better version of the site local scope. We didn't know what a site was, right? But a site, if you think of a site as a provisioning domain or a provisioning domain as a site, then some of those site local, some of the intent around the site local stuff kind of makes sense and kind of could work. And there are places in the Linux kernel where some of that site local stuff could possibly be revitalized and made instead to serve the purpose of a provisioning domain. Let's see, requests for PVDs that aren't there, I think you should not be allowed to just like you can't listen on an address that's not assigned to the system, you shouldn't be allowed to, you should be told that there's no network there if you try to request a PVD that's not there. You may want to relax that for certain privileged situations, I don't know. There's the per packet, whether or not to allow per packet PVD selection, maybe not, as we've been discussing. Once a source address has been selected, you are, and a routing table selected, you are committed to that for the lifetime of wherever that is. But it's doable on a per packet basis. But we don't at the moment. But, next, please. So I think the next 3 slides are just sort of me going through bits of the socket API, saying we could have, a thing where you want to receive in C message, the receive API. You can specify the PVD. I think here, what this would be is, you could call socket and then you could call set sockop to change the PVD to be that of something you had gotten from like a get PVD info call previously or something like that. If you wanted it to be not the default, not the process default, not the system default, you could, Dave Thaler is standing at the line. Yes, David.
Oh, do you want to keep talking to this? I don't know if you're down at the bottom, but it's okay.
I think it's all legible.
Okay.
So maybe even obvious, maybe intuitively obvious exercise for the reader.
Well, just a meta point that I think the interesting parts of this slide is different from all the other ones, and so I stood up on this particular slide.
The next 3 slides are
yeah,
similar.
I know it's in the same category. That's why I started out. This is the first one that's actually talking specifically about the sockets APIs. I think what would be useful would be to abstract this to say, what are the actual primitives that you need to do? Because you can phrase each one of these to say, okay, you need the ability to specify a PVD. You need the ability to, do X, Y, and Z as we talk about these slides. The mapping to the specific sockets API is actually out of scope for this working group by charter.
We would need to recharter if we wanted to define one, and it's there's a
Right,
whole complicated process about how to define one. We'd have to.
So I got up to say, let's talk about these as if they were not concrete and talk about what the operations are that we're doing here for the rest of this meeting, so we don't talk about that. You'd asked before about C or C++ stuff, right? Set sock opt and get sock opt are specifically by the experts, meaning the POSIX community, deprecated and considered to be horrible APIs because they're not type safe. And so all new functionality is done by adding new functions, not by using get sock opt or set sock opt. We ran into this when we did 3678, the multicast source filter one, where we started off this way and we then sent it to them for review and they said, bad. So we had to move all that stuff to an appendix and add new functions and stuff. So that said, I think the rest of the discussion we should concentrate on the abstract APIs and not talk specifically about the sockets APIs, but I think the content of the slide we can mentally translate into what's the operation that we're talking about here.
Got a quick one here, and I won't try to discuss it anymore. I want to point out, though, the source address stickiness. While I think I like that for some of the things that I would like to do at the network side, at the same time, I think the Quick guys went out of their way to make sure they had a connection ID and that the IP addresses could just change all over the place underneath and the session stays up. So maybe it's not a blocking thing. You need to maybe work it out, but there's probably some discussion to be had there.
Well, that's why in this proposal you would use the, you would set the IP PVD or IPv6 PVD option in the C message in send message when you sent the UDP datagram.
Okay.
If you wanted to use an unbound file descriptor UDP socket to just send on multiple PVDs.
Okay. Cool.
That's how that would work. So. And again, we've talked about what happens if we talked extensively about what happens if there's no PVD specified. And so I was thinking, this is what I had in mind for the force a file descriptor to be bound to one PVD. So next, please. And most of the rest of the stuff this is also when you create a socket, you essentially should inherit whatever your thread default is, and if that's not specified, a process default. But otherwise, basically, you can set this still later. You can set this with other calls would be the idea. If you had something specified in your thread, you could go ahead and just sort of use that right away. Bind we talked about earlier. This is where if the PVD is specified and an address is unspecified, then it's recommended the source address selection be restricted to the addresses in this PVD, right? As we had talked about on the source address selection slide at the beginning. Otherwise, if the PVD is specified and the address is not specified, if the address is not unspecified, if it's explicitly specified, you might get EAD or not avail, right? If you're in an IPv4 only PVD, or you might get ENET unreach or something. Add or not avail for bind. But otherwise, you can run with scissors if you want. This is theory, right? If you wanted to bind to one address and try to transmit on another PVD, you could take your chances. Next slide. So listen and accept. Connect is very similar to bind, but listen and accept is where you need help from the system to, especially on accept. If you have if you have a SYN coming in, like you want the response you want the SYN ACK to be routed correctly, and you want the file descriptor that's returned from that to be bound to the PVD of that traffic. And I think also it would be great, if you were listening to a file descriptor and that file descriptor was bound to a single PVD, that you're essentially only listening to the wildcard group of addresses on that PVD, and other traffic arriving on other PVDs to that same port that you bound to does not cause your file descriptor to become readable. This is going to complicate things inside the kernel, but and the idea of SO reuse adder and so on. But anyway, next slide. And here, yeah, so send message and receive message. The ultimate, like, you can try to, on a per packet basis, try to specify which source address, which PVD should be used for source address selection and routing on a per packet basis, which you might do if you're kind of a Cuisinart application, slicing and dicing your packets left and right and center. Next slide. So DNS resolution can be implemented without too much work if you maintain per PVD DNS server in search path state, and if you use the sort of, if you use some existing sockets API PVD support, you can basically open a UDP or TCP socket to a DNS server, bind, connect, etc., and away you go. It's actually quite implementable. And then, but how to fix some of the other APIs, I don't know. And given the fact that it's not in our charter, I don't know that we have to. But I do know that, like get name info, for example, doesn't have a way to specify any sort of hints. So you can't even sneak in an extra struct somewhere. And there's the old res query, resinit kind of stuff. And the new get DNS API doesn't have a slot for this. Get name info only has flags. So some thought would need to be put into how this should work. Next slide. I guess, yeah. So there's one other thing about whether or not, when a VPN comes up, should everybody have to know about it and be explicitly rebind to their VPN if they're bound to another VPN, or should their traffic just get magically stolen? Sometimes it's kind of nice if it just gets magically stolen, but maybe that only happens if you haven't specified any sort of PVD. But if you have, then you get blocked, or whether or not your PVD is whether or not the VPN should be bypassable or not. This is a very complicated sort of thing. I don't know what to do about some of that stuff. Again, we didn't talk about any of the accumulation of all this data and how the system should decide what belongs in a PVD and how it should answer questions from the application side. And then, yeah, there's a whole lot of policy and privacy things that are undecided. And anyway, there it is. Thank you.
So any further questions, comments, discussion?
Just very happy to see this work. Thank you very much for doing it.
I'm presenting other people's work.
Yeah, I mean, there is one
the question of what we should do, I think.
Kind of question, yeah, of how we want to go forward here. I mean, as a working group, we've got pretty much everything in last call that's currently in our charter. And there's a question as to whether we would like, as a working group, to ask our esteemed AD whether we can actually specify a sockets API for PVDs, whether we want to remain only doing a non-concrete API. So does it make sense? Do people think? Anybody want to leap up and tell me why I shouldn't ask that question of the group, whether we'd be interested in defining a sockets API for PVDs?
So I think the charter does say right now that we should be doing an abstract API. And so even if the answer is no, then there's still some interesting discussions that we're having.
Right.
Okay.
Right.
That said, I am not in favor of doing a sockets-specific API in this working group. By socket-specific, I mean C, C++ API. There's a separate group that is actually the standardization group for that. They're not the experts on PVDs.
Right.
Okay.
I mean,
so what I think the best behavior is that we specify how to use PVDs in an API, and then have the other group, which may have some of the same people in it, right? Have the other group. By the other group, it's the Austin group, which consists of part of IEEE, part of the Open Group, and part of ISO that kind of jointly publish POSIX, right? They're the ones that have all the expertise, like whether to use a set sock-op versus a function when you're doing C. JavaScript would do it for, W3C would do it for JavaScript and so on. But having a common template, okay, well, here's the operations that you have to have, and here's how they affect other things. Like whenever you do a connection, you're using the thing that was set as your default thread thing. That's all good stuff that is actually API agnostic.
Yep.
And so that's what I think is the value in this working group doing, and not doing the BSD sockets binding in particular, because I think that steps on the toes of another SDO.
Right. Well, one thing I would like to see is that the way I understand that previous IETF innovations have been included in that those standards is that we have written an informational document that defines a sockets API, and we don't standardize it. We write an informational document. They end up taking it. They change it until it's right, or they yell at us until we change it until it's right. And eventually we end up with an informational document that matches the what they end up standardizing for. So we end up with an RFC that's informational. They end up with an ISO/IEEE/open group. But this is a lengthy process. But the only way I know it's been done, and it's possible it's been done other ways, is for us to start by writing an informational document that gives our best effort attempt at what the sockets API should be. And so if there's a different way to do that, I'd love to hear that there's a different way to do that, because I remember it being a very painful process the last time I chaired a group that did this. But I don't know of a different process. Has something new happened since last I knew that we would start differently? It sounded like you thought we could send them something conceptual, but that isn't how. Have you been in a group that has sent them something conceptual and had that work? Okay, but there is no C API for GSS API, is there? Okay, but it was separated. It was published in an RFC. Did we write the RFC first before the Austin group made it exist?
In that particular one, I don't actually know whether the Austin group picked it up.
Okay,
but I'm saying it was specified as an abstract API, and saying here's the set of operations. They just had names and sets of input parameters and output parameters, which was language agnostic or whatever.
Right. We could.
And then there is a separate API that says, and here's the C binding, and I actually don't know because that's in the security group, and I wasn't the expert on that to say did that actually go through some other review.
I've coded to that API, but I don't think it's a sockets standard.
Do you have an RFC number for that, or for what the abstract one looks like?
I don't have all the RFC numbers memorized, only half of them.
So Dave, are you suggesting we should write an abstract one and not a sockets info document, or that we should write an abstract one and you don't care if we write a sockets info document, or we should write both? And I'm not sure which one you're suggesting.
I think that we should have an abstract one, which answers part of your question. I agree that there are various processes that have happened in the past and that continue to happen for how you get to a concrete one. I think there are multiple language bindings that are actually interesting, of which BSD sockets is one of them. Okay, and so I think the value in the abstract one is it becomes perhaps more useful to other language bindings than perhaps the C API. Now, you might argue, well, if all they're going to do is wrap the C API in this other one, then they could start with the C8 one, but that actually might propagate bad practice, meaning stuff that would not be appropriate in, say, JavaScript or C# or whatever else. They would be inherited because they saw that was how it was done in C, and it seemed like a good idea at the time, right? In the abstract one, they think about how to naturally do it in that particular language, and you get a better result. So I think there's still value in an abstract one. Yes, you're right that the IETF has historically done informational API things, as you said. And so I don't know that I strongly object to it, other than it's out of charter right now. But that wasn't your question.
Right. The question I was asking the group if we're interested in doing the work, so that we could, as a precursor to talking to our AD.
I would not strongly object to that if the process was to document it as informational after they had reviewed it or whatever. Having done that myself once, the challenge is that implementations start to implement the bad practice version. So in the example that I gave, we had multiple operating systems that had implemented the set sock-op versions, and we sent it to the Austin group, and they said, bad, 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 you should be doing new functions, and we had to figure out what to do about that. And so in that particular case, we ended up having to move all the set sock-op and get sock-op stuff to an appendix, because it was already widely implemented, meaning the bad practice, the stuff they said was bad was already widely implemented. So we moved that to an appendix and put the main document as being the functions, and then we had in our implementations to do things like, okay, we had to create a header file that actually implemented the functions as inline wrappers over the set sock get sock op, so it would work with an existing implementation merely by changing a header file, right? But that solves actually the programming problems because now you're doing it type safe, right?
Yep.
So it solves what they wanted, but we had to do this weird workaround. You get into suboptimal implementations by doing the get sock op, set sock op stuff first, and so I think we've had some
No, but we know to avoid that now because you told us. Well, it'll be the next thing that we find out.
But I don't know. Yes. So that's the danger.
Yep.
So yes, we've had some success in that saying, and sometimes it's not necessarily the type of the best type of success. But
I mean, as far as I know, the alternative is they don't end up defining socket stuff for these things, and that is maybe
I
not
think
a
what's
preferable
important is
outcome
making
with
sure
that.
that we actually get standardized sockets ones. And so, for example, the ideal case, I don't know how we get this, right? But the ideal case is that we're doing the abstract API, and simultaneously, the people from that other organization are participating in defining the concrete API at the same time, and then whether it gets published as an information RFC is not as important.
Yeah, I mean, that's
Okay?
never
If it's
been
done
how
by the same time
we've
frame,
done it.
I don't care
So
which
we
time.
can look into whether
Go
it's
ahead.
possible to do it that way, but I don't know that the IETF has ever done it that way. I'd like to know a group that has had success with that path.
Okay, putting on my AD hat, I'm inclined to say follow the charter, do the high-level API. How you get to there can be of anything. You can construct a wiki and share the experience of multiple bodies doing the work. Okay, that way you come to the right answer at the right time, and then all the other parts, and essentially reinforcing what Dave has said, get to the higher level point through the experience of everything else. You don't need to construct documents of all of the lower level stuff first, because I actually guess you're going to get it wrong.
No, I don't think we should do the documents of the lower level stuff first. We already have a charter item to do the high level one.
Then stick to that.
And not you don't want me to ask whether people are interested in trying to do a sockets API.
I don't think documenting the sockets API is going to be of value at this point. I think I want to see the high level document first. I want to see wikis or whatever other collaborative tools you can do, GitHub, you choose something more dynamic to get to the other space.
I mean,
as a guide to the high-level API.
Do you think the goal is to eventually have a sockets API, or you just don't think it's useful to have a sockets API?
Perhaps eventually, but right now, I think you're just going to be churning.
Because, I mean, I don't think we get applications written to take advantage of this stuff until we have APIs that they can call.
You're worried about timing.
No, let me worry about something else as well. So I want to worry about the opposite. Dave said that we can't actually, if we do it first, we'll get it wrong, and yes, we will. But you fixed it using a header file, right? So
for some definition of fixed, correct.
It could have been worse, right? On the other hand, if we had not had a concrete implementation, and we had an abstract one, we might have made logic errors or semantics errors that we could never have fixed using a header file. So I'm actually on the opposite side of this. I think that you can't actually build something. You can't actually design an API without an implementation, because otherwise you're in your ivory tower without your foundation. And I think we need some sort of at least proof of concept. And if we can do this as a draft that maybe never even becomes an RFC, I still think there's value to that, because otherwise we're sort of floating on. Okay. So yeah, that's what I want.
Yeah, and I mean, I don't care about the informational RFC. That's not what I'm focused on. I think it's hard to do. We've had a lot of trouble talking about an abstract API and becoming detailed enough to be useful. And as soon as you try to say, well, what would that look like in sockets? I know sockets isn't the perfect thing, and it's not the only thing, but it is something that all of us are familiar enough with that we can actually have a conversation where we say, well, what would that look like in sockets? I mean, that doesn't, sure, that's a nice abstract concept, but what does it really come down to if you're going to make a sockets call, right? And that I think grounding it that way can be really useful for an abstract API, right? Because you kind of are coming at it from both ends and making sure it's both abstractly correct and it actually can be practically implemented in at least one language that we know.
Dave again. So I want to make a specific suggestion, because I think what you're worried about is a timing, right? How soon can we get something that's a concrete binding so people can be playing with it? Okay, that's independent of what this working group necessarily is doing. That was the example that Lorenzo gave of maybe it's not a working group document with RFC status, right? So my suggestion is I think we should send a liaison to the POSIX community now to invite them to co-participate with us, that they're doing the concrete binding at the same time as we're filling out the abstract API. right?
Okay,
If
fine.
we're working together on this, then there's no reason for delay, right? It just so happens the document might be on their side or on our side. That's not that big of a deal to me. But I think what is important is to get them involved sooner than later.
Okay, and I mean, that sounds good, because the next question I was going to ask after the working group said they think there should be a sockets API, if they said that, was, okay, I need to work with Terry and whoever else to figure out how we actually get to one, and then we can make charter for what the working group has to do to make there be one. But I don't know. I mean, as I said, I've only been through it doing it one way, and maybe there's a better way, and we could talk to them and try to figure out if there's a better way. That would be fine with me.
I concur with Dave, actually. That sounds like the right-sized approach.
Okay. So, but I mean, we don't do anything, right, unless the working group is interested in doing it, right? And unless we have people who want to work on it, right? So, because even if we're gonna write, whether it's a draft or a wiki, I mean, we'll figure out where the bits are going to go later. But if we're going to work together on putting together an API that we're going to hope multiple people will use and implement and whatnot, we have to have a group that wants to do it, right?
Dave, do you have experience about how these other SDOs work? One thing that I heard from somebody whom I trust but who has very strong opinions, and I'm going to try to make it less arbitrary here, is that POSIX does not aggressively or preemptively sort of work on stuff. They come in after the fact and choose among whatever APIs have been deployed and implemented, and they pick one. That's what I heard. It was less complimentary than that, but that was the gist of it.
Sorry, this is a meta discussion, and I think you can take this offline.
What?
Huh? Yeah. But let's at least let's see.
Let me clarify how this is helpful to this discussion. Is that if POSIX does not usually work on new stuff, then it is appropriate for us to define some of the meat and then give it to them in a more advanced stage.
Okay, so let's just get a feel of the group. I think what we have is a proposal here that largely Dave has made. Lorenzo seems to agree with it. I don't want to call it anybody in particular's proposal, but that we continue to work on the abstract API and that we start an effort to, in one way or another, without knowing whether it's going to go to an RFC in the IETF or whether we're going to try to hand it off to the POSIX people, to start working on a sockets API that we think is a good reflection of the abstract API, so that we can make sure it's grounded. Do people in the group think that we should do that we should start working on a sockets API that reflects the abstract API and work on them in parallel? Or do people think that we should write the abstract API first and then try to work on a sockets API, maybe other APIs after that? Okay. So who in the room thinks it would be good for us to start working on those things in parallel, as we're defining the abstract API? Well, you do hands, because I can hear much better out of one ear than another, and it makes it very hard for me to tell hums. So the two things are, we start working on a sockets API now while we're also working on the abstract API, so in parallel. The other is that we work on the abstract API only. We ignore the sockets API until after we complete the abstract API, and then we decide whether we're going to do sockets or something else.
It sort of also matters who's actually going to end up implementing it and what they're actually going to do, right? So, and I don't know if those people, even if they're in the room, I think some of them are, I don't know if they know what they're going to do yet.
Well, I mean, I'm going to ask, do you guys think we should do this?
I'm going
to ask how many people.
Me, I haven't had enough time to think about it.
Okay, well, maybe we just want to think about it. I mean, we may come to no answer, right? If we come to the answer that we want to do it, I was going to ask who here is willing to work on documents for it and who here thinks that they might implement it. But
that last question may be all you need, because at a certain level, we can mandate from the bench all day long that you create 6 different versions in 6 different languages, but what you'll get is what people will be willing to do.
It's true.
Yeah.
But the abstract API is something it's in our charter. We should do it. This work I could recast as an abstract API, and as Dave said, speak in intents and abstracts, and this sorts of things should happen without removing the socket. Remove the socket.
We're allowed to do what, Lorenzo?
Pseudocode? You said pseudocode.
Pseudocode, yeah.
So I have Jabber Relay, comments from Ted Lemon and Keith Moore. Ted Lemon, I think we should do both abstract and concrete in parallel so that each effort can inform the other. Keith Moore, whatever else you do, please don't delay development of the sockets API.
So, so the question is, do people want us to start working, if we can, on defining a sockets API in parallel with defining the high-level API, or would people not like us to do that, which means that we define the abstract API and not start working on the sockets API in parallel? Okay, does that make sense as a question?
Shepard relay from Ted Lemon. He suggests using the term concrete API rather than sockets API in your question.
Okay, so do we want to? Okay, so Lorenzo, go ahead.
With the assumption though that if we do end up working on a concrete API, it may well never actually be standardized as such. It may just be given to another SDO, right? That was the yeah.
Yep.
Okay, so it would basically be a sort of an implementation exercise to make sure that what we were doing was actually sane.
We might put a wiki up and work on it that way. I mean, how we work on it will be determined after we determine if we want to work on it. But we might just put a wiki up and start working on it there or something.
Based on that, do you actually need to hum, since it's in your charter, to produce that that high-level API? And what you actually need is people who are willing to implement to get there. I see this as a move forward.
I don't see how we define an abstract API and people implement it. If we want people to implement the same idea API, we need to write down a concrete one.
Okay, concrete API.
Yep.
They will obviously have to get some implementation experience at the same time as constructing the high-level API, which you are chartered for.
Yes, we're chartered
Right.
for the abstract one. Yep.
Thank you.
Right.
Right. What is not clear about that?
Where I wanted to know if people wanted to work on a concrete one, and if so, if we can get a group together to do it. But if,
Okay, I think it sounds like it's a little bit premature for people to actually answer that. Maybe you should take that to the mailing list.
well, if there are people who want to work on it, send me email, because I'll try to get a group. I'll try to send you all to each other. I don't know, I'll send you all an email telling you who each other are. So if you want to work on this and you'd like to get together and work on it, send me email.
Keith Moore, I agree that a concrete API is necessary, but I also think a sockets API is necessary. And no, I'm not sure what the difference is, and so I asked him to elaborate.
Well, I mean, a concrete API might be a sockets one, or might be, I don't know, what, a .NET one, or a I don't know, something else one, a Java one. But if there are people who want to work on a concrete API, probably specifically a sockets API, send me email, and I will point you at each other so that you can start working on it. It would just be a design team, wouldn't be an official working group, anything, because it's not in our charter.
Now I'm Dave Thaler. One of my roles in the IAB is the liaison, not Shepard, but the relationship to the organization that owns C++ standardization. The contact person is me, so if there were a liaison to go, since we don't have an official liaison relationship with them, we don't have a liaison that's appointed, and so it kind of follows back to the IAB, and so right now your contact is me. And so I have the contact information for the group and know how to get stuff back and forth, even though there's no official liaison relationship with the organization.
Okay. Well, we'll
and
start
so
in the background.
I'm happy to be kept in the loop in whatever way I can help. So
in the background, Dong Hui and I will start finding out how we would contact any of those people, including talking to you. Anybody here know how to get in touch with the Austin group? Anybody here have contacts there? You? Oh, is that group? Okay.
The Austin group is just a term for a combination of three organizations, right? One piece of the IEEE that does the POSIX specification, one piece of the open group, and one piece of ISO, right? That collective body of three things is together called Austin Group. And so technically there's a contact in each one of those organizations, but they only publish one thing, okay? And so I've talked to one of the head people in, I think it's the ISO that has the C++ 11 specification, the person that's over networking and stuff. I have that contact information directly. And just because right now it happens to be headed by somebody at Microsoft, and I can walk by his office across campus and talk to him in person.
Okay.
And so, and he has the other contacts and stuff for me.
So we'll talk to you offline about talking to them about what the best way to get to a sockets API would be.
I don't know that it makes sense for people to work on a concrete API without talking to the people who are actually working on the API. So when you say, tell me who's interested in working on a concrete API, and I will put you guys together, I think what you should have said is, tell me who's interested in working on a concrete API, and we're going to put them together with the people who are working on the abstract API so they can check each other's work.
Yep. I want to know who's interested in action. And by working on a concrete API, I don't mean you like the idea of concrete APIs. I mean people who might actually implement a sockets API somewhere for this, or are own a sockets API to something else and want to actually work on getting a set of concrete implementations of something that matches the abstract API.
Could you ask for a raise of hands of anybody who wants to work on an API, any kind of API?
Yeah, how many people here would be interested in working on a concrete API to match the abstract API?
I'm Ted Lemon, raising my hand based in the Jabber room.
Okay, that looks pretty good. Looks like enough people anyway to get something underway. So well, I think there were about 9 people, but somewhere in there. But that's plenty of people to work on an API. So if those people want to send me mail, I'll point you at each other, and we can go forward.
There's the API design team mailing list too, right?
Yeah, but that's that's kind of in theory for the abstract API, but I will get that group all we won't leave them off the email.
Yeah, it should be everybody, even the concrete people.
Yeah, and we'll figure out what to do with it once we get some emails from people and figure out what the overlap is with that group and whether it makes sense to have 1 group or 2 groups, or I don't know. I don't know how to organize this, but we'll figure that out. So anyway, thank you, Eric. Are you done? Is that?
Yeah.
Okay.
I'm done. Thank you.
So I think this is really promising. So
I think what I need to do next is try to make this into a start of an API abstract document, and send that out to the API mailing list and the MIF mailing list, and then see what
sounds
happens
excellent.
next.
Thank you.
Thank you.
Yep, we've got Gangliang.
You have standing in the square, so.
Yes, I'm in the box.
Okay.
Let me just make one comment before we do this about what this is about. This is a presentation on what we would need in HomeNet to reflect MIF PVDs. We don't standardize HomeNet here. If we have agreement in this group that we need something from HomeNet, we have some HomeNet chairs over there, and we will interact with them and tell them what we think we need from HomeNet, and hopefully they can take it from there. So. But the idea is to get some agreement in this group about what it is that we might need in HomeNet that isn't already present. So you can start now. Go ahead.
Thank you. Yes, so these drafts essentially talks about the use case for HomeNet with the MPVD ideas. So next slide, please. Taking a typical HomeNet architecture, this is the architecture from the published Home Architecture draft. So we have multiple ISPs providing multiple interface to separated customer edge routers. And in the MPVD ideas, all these 4 hosts in here are MIF nodes. So essentially in this kind of HomeNet scenario, the provider A and provider B could provide different PVD through the ISP network and the HomeNet network to the end user, to the host. So in here, we give an example of Internet PVD from provider A or the Internet of Things PVD from provider B. So in this scenario, since the PVD information needs to be passed from the ISP network, which is not a HomeNet network, that is basically what the conveying of the information of PVD in that network has been well identified in MIF group. But below the customer edge router in this diagram, which is in the HomeNet scenario, there is still need a approach to actually pass the PVD information to the MIF node, which is the HomeNet hosts. So next slide, please. So conveying the PVD information in HomeNet, since HomeNet HNCP is used to configure the internal nodes, the prefix and things. So we need HNCP TLVs for PVD information. So we propose that to match with what has been defined in MIF using RA or DHCP options to pass the PVD information. We propose to use PVD container TLV and PVD identity TLV in HNCP to enable the conveying of PVD information at HomeNet. So next slide, please. So next steps, as Margaret has said, we do need some discussion of which part of this work should be done in MIF or HomeNet. So any comment from MIF group would be very appreciated. And we'd like to define the proposed two TLVs in HomeNet using HNCP. So that's all for my presentation. Thank you very much.
Any comments on this? Whether people agree we should be trying to define these kind of TLVs? Think it would be nuts to define these kind of TLVs? Any thoughts?
Take about why can't arrays not being used for distributing this kind of information? Why do we need to use other protocols?
What was that?
Is it on? Yeah. No.
He said, why can't RAs be used to distribute this information? Yeah. Why do we need other protocols?
No. Well, because the nodes in the HomeNet don't communicate with one another. The HomeNet architecture with HNCP performing its function is handling the prefix configuration. Okay.
Maybe back to the diagram.
Yep.
So here there are arrays from the edge routers towards the host. So.
Yep, but between the service, well, actually, imagine there's more than just two.
Okay. Other scenario, but
there's a set of routers, HNCP routers.
If you have multi-hop topologies, there can be array information spread all over the HomeNet, right?
Now you're redefining how the HomeNet works. So that's not this working group. So if you don't understand it, we can talk about it later.
Let's take it to HomeNet.
Cool. In HomeNet, other similar information is distributed via TLVs via a protocol called HNCP, which is a profile of DNCP. Right. So.
Anyway, go ahead. No, I mean, I'm not sure we want to redesign everything at the moment. What I was going to say.
My point is the information is already there. Yeah, each link in HomeNet has the array, right, for the host because the host needs it already.
So there is a router sitting. I mean, excuse me. So there in the home network there's is a bottom router sitting between the host and the CPU router.
Yeah, let's take it to HomeNet.
Yeah, it's Ray Bellis, the other HomeNet co-chair. If we could do all this with RAs, we wouldn't need HNCP in the first place. And we do need HNCP.
Yeah, I mean, HomeNet meets on Thursday, I think it is.
Wednesday, tomorrow.
HomeNet meets tomorrow, so if you have issues with HomeNet, you'll have to take it there.
So I was going to say, and there was a race condition coming to the mic, that it would be very, very convenient for HomeNet to propagate information that it's receiving from the ISPs, the provisioning domains, propagate it through, and us not have to worry about it at all, hand it over to the host, and the host deal with it as you're working very hard on now, right? I think in most of the cases we should be able to do that. The implementers there will correct me if I'm wrong, but at a high level it seems like it would work. There may be some cases where the HomeNet routers themselves may have information or may be part of its own provisioning, okay? And those are some edge cases we need to think carefully about because, what that information that's born within the home, which PVD does it go in, right? Yeah. So that's the harder part. But at the base level, transparent would be really nice.
So would it be useful, do you think, for Gangliang to define these TLVs and bring them to you guys, and then you could discuss in HomeNet, everything? I mean,
Yeah,
we wouldn't
he's on the
standardize them
agenda
here.
tomorrow.
You'd standardize them there if they're going to get standardized.
Well, if it's a container, yeah, right?
Yeah.
But we need to, I think the overlap, well, first is the decision, can we do it transparently with a container? If both sides agree that, yeah, we'll worry about the details in HomeNet and put it somewhere. And then, but we need to get together and have some serious thoughts about whether or not there's more detail behind that.
What's the best way to do that, to get together? You want
I'm
a
free
few of
after
us
this,
to
yeah,
get together
I mean,
separately, or you want to have?
Let's meet after
Okay.
here.
Yep, good. Go ahead.
Markus Stenberg. I was just about to say that, if this stuff was per prefix, it would work automatically because we pass along all unknown options as is. But as it's not per prefix, but instead something weird between an interface and abstract concept and bunch of prefixes or something, there is actually a need for a different degree of containers within HNCP and also support for that stuff. And it gets really complex, so it's not causing much happiness for me. And until I actually see some concrete need for it, I would rather not specify it at all because it makes existing implementations much more complex. And I would like to see need for actually people who are actually interested in implementing that complex stuff before I write it, because my historically speaking, all complex stuff I have written has been more or less deleted at some point. So I don't write it unless there is implementers. Let's put it this way.
Stephen Bard, maybe to elaborate a bit, but it's like thing. Anyway, as Marcus mentioned, we have a generic way of passing on DHCP6 options in HNCP. So if it's just your MPVD options for that, you could stick it in there as is, and they would be distributed along all HomeNet routers. But the problem is here, I think, I haven't read the draft completely, but I think you're using OROs in the DHCP6 draft to determine if the client is actually capable of that or of receiving these options. And then it gets to not only that, but then you have the case, is your CPE on the ISP edge capable of that? And then how does it put that into HNCP? Because is then the server on the interior router also a MIF router? Is it capable of dealing with that information? Is it capable of detecting if the client can deal with MIF information? And then, yeah, the third point is the client, is the real client at the end, the host device actually capable of that? So what we would have to do is, at the edge is probably, we need to have the legacy information, which is not in the container. So we can spread that out usually for all legacy non-MIF capable routers and hosts. And in addition, we would need to have the MPVD containers, which we should also put in there, but only give out to servers on interior routers which support, delegating them to clients which support them. So it's, yeah, it's a bit awkward. Yeah.
So there's Krishnan. So just a question for you, Steven. So how does this HNCP to DHC dissipation work, right? Like, so you need to handle this generically, not for just the PVD. So if you get an ORO and there's a DHCP server sitting on the router, right? If that's something that's opaquely passed on from somewhere higher up, you need to handle it anyway, right? Because when I send an ORO, if you don't know if that option is going to come, and it's going to be passed on from somewhere else, and you're passing it along.
No, the problem is that if I got the draft, if the MIF draft right, please correct me if I'm wrong, is that the MIF capable ISP router or whatever box differentiates between if the customer router sends an ORO for the MPVD stuff.
Exactly. Yes.
And the problem is that it would need to have both the legacy information for clients and interior routers not supporting the MIF stuff, and it would need the MIF information for hosts and routers capable to do that. So that is currently not needed for anything else, because at the moment, either the option is there and a host cares about it, so we pass it on, or we just have the information in HNCP, but the host doesn't ask about it. So we don't care about it really. So,
but it's not. This is not a singleton option, right? If you look at the software options, it's the same thing, right? So unless somebody asks for it, you don't give it. So like somehow this information needs to be passed along. So there's like two ways to do it. Either we pass along the intent to get the things, or you ask for a superset of things that you think you want to hand out.
Yes, but the problem is that the legacy information might be different in this case. You know, I mean, for the soft wires, you don't care because soft wires end up being terminated on the CER usually anyway. So that's not the point.
I don't understand what you mean by legacy information might be different. The only thing held in this option is the MPVD name. And so there is an MPVD name or there isn't, and someone could request it or not. I'm not sure what legacy information would be different.
No, I mean, I'm more talking about the container options here, about the what you could place inside that option. If I got that right, you can like add custom DNS servers for this version. Yeah, maybe.
There is also lots of stuff there that assumes that, you know, you can authenticate this stuff. But for example, the prefix stuff, it changes because we subdivide the prefix. Some of the other stuff might also change. So as a result, all of that handling with magical authentication of everything passed as is a false assumption that is unlikely to work unless we work hard at it. And as I said, I'm not motivated to work hard unless I'm proven somebody's going to actually roll it out.
Ted Lemon, Jabber Relay. I think we want HomeNet routers to be MIF capable. Perhaps that's the wrong thing, but I don't think that's obvious.
I didn't hear. Perhaps that's the wrong thing. What?
I think we want HomeNet routers to be MIF capable. Perhaps that is the wrong thing, but I don't think that is obvious.
I mean, I think you might translate that, and he can pop back and tell you I'm wrong as, is there some reason we're not requiring HomeNet routers to be MIF capable?
That's how I'm reading it. I'm reading it as Ted thinks, okay, I mean that we should consider the question. It's Ted's response.
I would say that ideally, once all of this stuff is, say, standard track documents that somebody has actually implemented, I'm perfectly happy to define this stuff. But until it's something hand-waving in a working group, I'm very unhappy to do any substantial changes to anything based on that, because it can change. You guys can change your mind. I can change my mind. And it's just, it will never terminate if we wait for any random working group to come up with new ideas. And yeah, okay, fine, let's continue.
I mean, we have documents, some documents that are, well, RFCs, and, and they have been implemented. Okay, so I'm not sure what point in time you're waiting for.
Well, I'm waiting for the time when I have a client I can plug it into my router. I have an ISP that provides me with the PVD information, and I can do the magic that makes it multiple CPs work like one CP. Up to that point in time, I don't see a point. I mean, sure, working against the developed specifications is fun and interesting, but if it requires actually substantial changes to anything and nobody else than me is actually going to implement it, I don't see the point.
I mean, the point isn't to make multiple CPs work like one CP, so I think there's some confusion.
Wait, I want to break this. Marcus is talking about implementing. We can certainly, and the whole, you know, fun and dandy to write specifications, but we can, even without writing a specification, we can sit down with a napkin and design how it should work. Yeah. So that MIF does their job, the ISPs do their job. Even if you want to order your implementation after the two, they need to do it in a way that will actually make it easier for you later. Okay?
Yeah, sure. As I said, someday it will be interesting. But from my point of view, currently it feels awkward to say that, yes, HomeNet has to do it. Certainly within some finite period of time.
HomeNet has to work with MIF to make sure that we design something that's compatible, right? Whether you have to implement it, well, that's up to you, right? I mean, we should at least look at the problem because we intersect here. And your points before were very, very salient.
I'm still Ted Lemon explaining what he wanted. He said, my personal opinion is that we want them, HomeNet routers, to be MIF capable. But I'm not sure that this is true. The reason that I want it is that it's pretty clear what we need based on the MPVD architecture. And HomeNet basically doesn't work well without MIF.
Maybe to elaborate on the point that Mark made, I mean, as I said, in theory, we have the capability in HNCP, and that's what's currently implemented, to carry arbitrary DHCP6 options. If that is the only requirement for MIF and I don't know that that's what this working group should decide on, then that's possible. And then there may be additional requirements for the DHCP6 server parts on the HomeNet routers to do X based on there being MPVD information and client capabilities there. But this doesn't really concern HNCP as much as, I don't know if you need those additional TLVs if you, that generic DHCP6 spreading mechanism in HNCP is already enough.
It's part of it. I mean, you said it. Sorry.
Oh, go ahead.
I mean, you said it a moment ago, I think yourself or maybe Marcus did. For some things, you can transparently carry it through. But for other things like, oh, we're going to take that prefix of yours and carve it up, right? How does that affect the PVDs, right? And we need to at least think about that.
Yeah,
right.
And
and there's also, oh, I'm going to discover for you which, PCP server or which this or that to use and choose it within the home and hand it out to the hosts within the home. Is that a PVD or which PVD does it go in? I think there's stuff to think about.
That's my point in saying that. I'm just saying HNCP has this mechanism to distribute the HPV6 options and make them available to all routers. Does MIF need that? Does MIF need anything more, anything less, something like that?
I do have an answer for you, okay? So that is like the basic stuff that's required. So the MIF container option for DHC is a valid DHCP option, DHCP-V6 option, okay? So it's going to pass through. But my question, which is not relevant in this working group, but I'll ask tomorrow in HomeNet, is that how do you pass on ORO so that you get this opaque option back? Because that's something HNCP requires, and not for MIF, but for everything else. Because like if you don't have the capability in HNCP to pass on an ORO towards somebody who will give you that information, you're not going to get that information. Okay, but we can talk about it in HomeNet.
No, I mean that's the case. Then your edge router has to do the ORO on behalf of the HomeNet.
How does it know? How does it know what the client wants? So either it needs, that was my first point. Like either you need to do a subset of things you know about.
There's another issue when you talk about OROs. Is the specific ORO required or significant for this specific router? Like, is it like a FQDN option that is requested, or is it a software tunnel that ends directly on the CER? Or is it something that the network wants? And this is another hard part. If you do not know where or what's the domain of an option is, then it's hard to say, okay, I'm just on behalf of that other one requesting this ORO, and then I spread it out, even though I don't know if the option is directed at me or at the whole network.
That is a tough problem, yes.
Ted Lemon, again from Jabber. The thing that routers need to do is come up with PVD IDs for the providers they're connected to, because we're trying to make home nets work with status quo ISPs. So the answer to that is that there is more than just DHCP options. The routers may not get any information, but still need to announce different PVDs for each provider.
There's work to do.
Yeah, we can start from the basic, maybe, right? Other than the full functionality.
So I think that the answer is Mark, Ray, Donghui, and I will stand together out in the hallway and discuss this after this meeting, and people of strong opinion should cluster. Yeah, okay.
You done? Yeah. Close to closing, yeah?
Yeah, I mean, we've got our we're done with our agenda. And
okay, cool. So this is Terry putting on his AD hat. Working groups are there for a reason. They do work. Now, I don't say this lightly because MIF is at the cusp of calling success. Okay, so it's really important that that work happens. Mailing lists are the center to that work happening. I see a lot of enthusiastic people here, but that's not reflective of what I see on the mailing list. And there are more people on the mailing list than there are in this room. Okay, face-to-face meeting time at IETF is very privileged. And when you think about it, it's phenomenally expensive. You look at all of the people in this room on their salaries and you take 2 hours of their time, that adds up, okay? So also think about that in the IETF context and the call for meeting time across all of the working groups that we have. So I'd really like the working group to seriously consider the amount of effort that goes into the work, both on the mailing lists and in this room. There ends the grumpy AD sermon, but I'm quite sure you get the point here, yeah? Thanks, guys.
Okay. Yeah, so we have two mailing lists. One is for MIF working group. The other one is for the MPVD API designing. So anyway, we will move more discussion into the list. But before that, I would like to get a blue sheet from that side. Can you raise your hand if you have a blue sheet? And also this side.
I mean, I think, Terry, one of the reasons you don't see a lot on the mailing list is that I mean, at this point, all of our active items are in last call except our API, which we've had a little trouble, and I think Eric's helping us restart that. So
that's accepted, but we've got that one thing to come, and don't
and
take your foot off
Ian
the
helped us out
accelerator
this
now.
morning, so so hopefully we'll have some lively discussion of his comments. So we're adjourned, if anyone didn't notice. Yeah, bring the blue sheets up here, please. Blue sheets. Somebody have a clipboard with a blue sheet on it? We only have one of them up here. Oh, I see Eric has it. Well, no, but I'm saying document it, get it right, come with a drop thing. Here's how we did it. Yeah, it's it always sucks when they come. Yeah.